Hi again, grade 12s. The question we're going to be dealing with now is from exercise 7.2 of your Clever Maths textbook. This is number 6. So the question reads as follows. In the diagram, WX is a vertical mask standing on a horizontal plane X, Y, Z. Also, given our angles Z1, which is alpha, Z2 is beta, ZXY is theta, and ZY is K meters. Give the magnitude of angle Y in terms of theta. Right. The first question requires us to look at the angle inside this particular triangle here. All right. So we need to find what that angle is. We know that sum of angles in a triangle add up to 180. So that's the reason you're going to use to work out what angle Y is. All right. So with this particular question, we want to express Y in terms of beta and theta. Okay. So we know that 180 degrees is going to be equal to beta plus theta plus your angle Y. Let us make Y the subject of the formula, okay? This becomes 180 degrees minus beta plus theta. Okay, so that's the first part done, A. We now want to prove that WX, okay, which is the horizontal mast, is equal to K sine theta plus beta tan alpha divided by sine theta. Now, when we are proving this particular part of the question, we're going to need to do it in 2 steps, right? We first need to work out what this length here is, okay? Then after that, we need to work out what WX is. Okay, so let us go ahead and first try and figure out what XZ is. We can use the sine rule here. The sine rule, we know that it says in triangle ABC, let's say you're given a triangle with the vertices A, B, and C. We know that sine A over A will be equal to sine B over B, sine C over C. This could also be flipped over, so you could have the sides on top, A over sine A, B over sine B, and C over sine C. Now, with respect to this particular question, right, I am going to express it as follows, right? The length XZ, okay, which is the blue one that I highlighted, is directly opposite your vertex Y, so that's why we're writing it as XZ over sine Y. This would be proportional to the ratio of ZY, okay, which is that side, over sine X. Okay, now we need to then plug in the values that we do have. We worked out Y earlier, right? We said that Y is equal to 180 degrees minus beta plus theta. Okay. This is then equal to ZY, which is K, over sine X. And sine X is just sine theta. All right. Now, making XZ the subject of the formula, you're going to cross multiply. You end up with K multiplied by sine 180 degrees minus beta plus theta. Okay, and that is divided by your sine theta. Now, looking at this part of the question here that I'm highlighting now, the 180 minus beta plus theta, we can use our reduction formula to make that theta, it becomes sine beta plus theta. Okay, everything divided by sine theta. So that is xz. Now, after we have that, we are now going to use our trig ratios. Having found the length of xz, which is this part here, right? We are now going to use our trig ratios, okay? What trig ratios do we have here that we can use? Now, with respect to the angle alpha, okay, they want us to work out what wx is. That is the opposite side. What do we have? We have the adjacent side, which is your xz. So, which is your trig ratio there? That is your tan alpha is equal to opposite side over your adjacent side. Right. Now, using that, let us substitute in what we do have. We know that the opposite side is wx. We have tan alpha. What we just worked out was the k multiplied by sine beta plus theta divided by sine theta. I want to make wx the subject of the formula, so that means I'm going to cross multiply, okay, and I'm left with tan alpha multiplied by k sine beta plus theta being divided by sine theta. Does it look like what they wanted us to prove? Yes, it does. So this is our proof. Okay, that would be how you would prove wx. The next part of the question is straightforward. All you have to do here is to plug in your values. They actually want us to determine the value of wx. Okay, let's say you weren't able to prove b, you could still work out what wx was, because they tell us that k is equal to 116.4 meters, alpha is equal to 56.2 degrees, beta is equal to 27 degrees, theta is equal to 102.8 degrees. What I then have to do is sub in all these values to wx, which we just worked out in part B. All right. So wx, we're substituting it in there. It becomes tan 56.2 degrees. K is 116.4 meters, right? Multiplied by your sine beta plus theta, 27 degrees plus 102.8 degrees, divided by sine theta, which is 102.8 degrees. Plug this all into your calculator and our answer is 137 meters